Right, hi guys. So we're going to be solving this particular question. This is a source-free RC circuit. So they want you to find the voltage in the capacitor, the voltage across the 6 ohm resistor, and the current flowing through the 8 ohms resistor for t greater than 0, t greater or equals to 0. Basically, this just means after the switch has been open. That's just what it means. They're giving you the initial voltage in the capacitor. That's after the battery was disconnected. This is the initial voltage that was inside the capacitor. To find VC, VC is going to be equals to VC at a particular time is going to be equals to the initial voltage in that capacitor e raised power minus t over something called tau. It's called time constant. This is the formula. The reason why it has this e raised power negative this thing, I feel like I explained like 2 videos now. Basically, it's because after the battery disconnected, VC will start discharging its voltage. So this will go from 45, 44, 43. You get, so that's why it's e raised power negative. Just check e raised power negative 2 online. You see it's a downward sloping graph. So first let us find tau. Tau is equals to Req times C. So just simply evaluate Req. This is in parallel with this. So Req is going to be equals to 12 in parallel with 6 plus 8. Because it now become in series with 8. Everything is equals to 12 ohms. So this will be equals to 12 ohms times 1 over 3 farads, which is equals to 4 seconds. So which means VCT will simply be equals to what's the initial voltage 45 e raised to power what is t and then what is tau 4 seconds. You can bring it up to become 45 e raised to power negative 0.25 t if you want. Next you want to find Vx, which is the voltage across the resistor. I like to think of VC as the kind of battery source for this particular circuit. So I like to redraw my circuits like this. Don't draw this for a lecture. It just helps me to picture things well. So I feel like when you look at it like this, you can easily find Vx now with like mesh analysis or circuit theorems. In this case, I'm going to actually use something called VDR because voltage is going to drop here and the voltage here is the same thing as the voltage here. So voltage is going to drop here, then voltage is also going to drop around here. So I can use VDR. I can combine these two circuits because the voltage across them are going to be the same, so it's not going to skew my data or something like that. So 12 in parallel with 6 is actually going to give you 4. So this simply to get this Vx will be equals to 4 over 8 plus 4, that's this 8 times Vc. And Vc in this case, we know Vc is what 45 years per minus 0.25, not 0.02, sorry, loss t, which is going to be equal to 15 e minus 0.25 t. That's simply it. Then lastly, to find I naught. I naught is simply the current flowing through the 8 ohms resistor. I would like to use nodal analysis for this. Well, not nodal analysis, Ohm's law. You see, I know the voltage here. It is Vx because that's the voltage that is coming around this corner. And I know the voltage here. The voltage, whatever voltage is here, is what is Vc. So I can simply say that IO is equals to Vx minus Vc over 8. If you're familiar with circuit theorem, you understand what I'm doing here. Or actually, nodal analysis, you understand what I'm doing here. So this is V higher minus V lower over the resistor that the current is passing through. You can check out my videos on nodal analysis. This is going to be 15E. It is going to be 15E raised to minus 0.25 T minus Vc in this case is 45 E raised to minus 0.25 T all over 8. You simplify this and you get to get your answer as I naught is equals to minus 3.75 E raised power negative 0.25 T. This is your final answer. Thank you for listening.